Welcome you guys back to the third video. So in the past videos we have seen that we have different layers in our convolution neural network, namely convolution pooling, and at the end we have the same ANN architecture, fully connected layers. So these initial layers are famous for feature extraction thing, and one of the reason why we go to deep learning approaches are they are good in feature extraction itself. We don't have to pay much attention towards extraction of the features and toward manual feature extraction. So this feature extraction in CNN case is done by convolution layer and the pooling layer. And let's just proceed and see what are these different layers like convolution. So convolution layer. So most of you might be new to this term. What is convolution? So let's not look to the mathematical concept. Let's just answer my first question. There is one image in the upper corner where you can see um, we have lines horizontal and vertically placed, and I want you to do something which can take out just the vertical lines. Can you imagine of a way in which we can find out just the vertical lines? Anything you can think of. If you guys know about it, you can pause this video, go in the comment section and comment down there that do you have any way so that from this image we just want the vertical lines, can we have that? Okay, so let me answer this question. So this can be done using convolution. So let's say we have the image, which is the first image, and we convolve it using the filter one. So we have the term which is known as filter. So for now, just imagine filter as an image, okay, small image. You should know that an image comprises of pixels, and each of the pixels will be having the values ranging from 0 to 255. So just imagine that this filter is a 3 cross 3 filter which is having, let's say, 3 into 3 9 pixels, and you will be convolving our original image with this filter, and the result will be the image which is shown down. You can see the vertical lines, right? So we have successfully found out the vertical lines from our original image. So isn't it cool? Like you will be able to find out like, the kind of edges you want. So using this kind of filter, which is filter one, you find out the vertical edges. Now if I ask you to find out the horizontal edges, can you do that? So you can do that using the filter 2, and you go for convolution of both original image and the filter 2, you will find out the result which is shown now. So here you can see we have the horizontal lines. So isn't it making sense to have the convolution operation? Let's say if you have an image of a person, and if you want to find out the vertical edges, it can be your nose edge, horizontal edges like it can be your eyebrow. So this kind of features of your images, no, they are comprising of small other features like horizontal edges, vertical edges. Each can be at the angle of 45 degree on any angle. So we want to have such kind of filters which when convolved with your original image should extract out this kind of informations out of your images. And this makes sense, right? If you are able to find out this kind of features from your image, you will be making a collective decision based on that. So this is what convolution operation is capable of. And let's see what convolution operation is. So imagine the input which is given here, which is starting from 4. That is an image which is having pixel. So first pixel value is 4. It can range from 0 to 255. For example, we have taken in between values from 0 to 10. So you can see we have the value 492562245. And if you want to perform a convolution of this whole image with respect to the filter which is given as 11100 minus 1 minus 1 minus 1. So what you can do is you just have to take that filter and superimpose. You can superimpose this filter. Let me try this filter. You can take this filter and superimpose over here, and what you have to do is you just have to multiply them. 1 into 4, 0 into 9, minus 1 into 2, and you just have to perform this operation and just need to add it. So this is what that can be seen in here. You can see each of the pixel is multiplied individually and they are added, and the result you can place it over here. You can see, right? So this is what one convolution operation is. You just the next thing what you can do is you just have to shift that thing. You just shifted it by the one horizontal pixel, right? So you just have to slide that window, and you just have to perform that operation again, and you can place the result over just beside of the first result. You can see it here, right? So this thing is known as stride. Okay, how many pixels you want to jump from? So here we have jumped only one pixel, right? One pixel to the stride. So this is what the term stride is. Stride is how many pixels you want to skip on. Here you can see the stride is 2. So you have this option. Whenever you're gonna code your first convolutional neural network, you will be free to select the strides. Then what is padding? What is the padding? So what happens is when you do convolution operation, you don't have the output as the same image shape. So if you see in here, you have the shape of the image as 1 2 3 4 5 6 6 cross 6, and the output is 4 cross 4 after convolution with this filter. And generally what happens in your convolutional neural network, you stack up multiple convolution layers. And if the initial convolution layer is giving you a smaller output, and if you feed the smaller output to the next layer, definitely this is gonna diminish. And if you have a deeper network, then this thing won't even reach at the output properly to make out the decision what we want. So we want to skip out this option, and that's what we want to skip out that problem, and that's what can be done using padding. So padding, what it does is you can have this 0 0 0 0 at the edge of your images, and what you can do is again you do convolution operation, and you just have to place your result, and at the end you will get image shape which is not smaller than your input shape. This can be managed whatever you want. If you see in here, if you have look at this first option, first example, you have an input image, you have a filter, and when we convolve it, you get an image of 2 cross 2, right? And now we have done a padding, and after that convolving, we get an image of 3 cross 3, output of 3 cross 3. This is not that much small, right? This is very much smaller, right? 2 cross 2. So get the feel of it what padding is, and if you manage out padding properly, you will be able to get the shape same as the original shape. So if say this is our shape, so we'll be getting exact shape out after the convolution operation, and will not be losing out much pixels. So for example, we have taken it 6 cross 6, but this is 1 2 3 4 5 6, yeah, 6 cross 6, but original image can be of varying sizes, what I've told in earlier videos. Like nowadays you click 42 megapixels of images, so imagine it, how much rows and columns will be there. This is just an example purpose. So this is what we have concluded in our this video. We have concluded what convolution operation look like, and what it is capable of, how it can extract out the features, how it is performed, and what is stride. Stride means how many pixels you want to jump, and what is padding. Padding means you can pad zeros at the edges of your images, and you can avoid that problem of shrinkage of your image in the further layers. So next question we get is what is kernel size for CNN? We'll continue this question in our next lectures in further videos.